Hey everyone, in this video we're going to be looking at 1.1 day 1 function notation. In this video we're going to talk about how to express a solution set in 3 different ways through the number line notation, set notation, and interval notation. And we'll also look at the use of and or in sets, also known as the union and intersection. When we talk about sets in math, what we're talking about is a collection of items. Typically, we'd refer to numbers, but a collection of items could be anything. It could be places, objects, people, things, pets. As long as there's a reason why those items belong together, there's a certain rule that groups them into a set, you could have a collection of anything. So for example, we could ask who plays an instrument and create a collection or set of the people who play an instrument. And we could have this be very vague, just anybody in the whole world who plays an instrument, or it could be more specific. For example, I could look at the people who play an instrument in my family. I play the saxophone, maybe not very well, but I have taken lessons at one point. My brother plays percussion, and my mom plays the piano. So 3 items would belong in this set. There are 3 people in my family who play an instrument. We could also look at people who play a sport, maybe people who play a sport professionally, or people who play on the Minnesota Lynx team, and we could create a set of people that belong to this category as well. Again, as long as there's a reason or a rule why those people or items all belong in that group, they can become a set. Here's what set notation looks like. We have some curly brackets at the beginning and the end of that set. At the beginning, we have x and a colon. We read that as the set of all numbers such that. What comes after the colon then is the rule for what types of numbers belong in that set. So here in set notation, we have some inequalities. The description here is that x has to be greater than 2, x has to be less than 5. This symbol in the middle here, it kind of looks like an upside down U. That is called the intersection. It can be thought of as the word and. So in this set are all of the numbers that fit both x is greater than 2 and x is less than 5. If that symbol had been a U, this is called the union. It represents the word or, meaning that only one of those 2 qualities would have to apply to the number in order for it to fit in that set. So union or, only one of those characteristics needs to be true. Either x is greater than 2 or x is less than 5. The intersection and means both of those characteristics have to be true. So the only numbers that would be in the set, again, are the numbers that are greater than 2 and less than 5. So let's take a look at a set in more detail and talk about other ways we could represent this set. Here on this slide, we have a very similar set to the one on the previous slide. However, one thing has changed, and we'll get to that change in a second. But again, you would read this as the set of all numbers such that, and then after the colon, we have the characteristics that need to be met in order for that number to be included in this set. The first characteristic here, x is greater than or equal to 2. The second characteristic, x is less than or equal to 5. And then this symbol in the middle, again, is the intersection. So we want the intersection of those 2 characteristics, meaning our numbers have to fit both qualities. X is greater than or equal to 2 and x is less than or equal to 5. Hopefully you caught the one change from the previous slide. And that's what the inequalities here. We now have or equal to, so both 2 and 5 fit into this set since it's greater than or equal to 2 and less than or equal to 5. These are what we call closed inequalities since we are including the boundaries of 2 and 5, greater than or equal to, less than or equal to. The other types of inequalities are called open inequalities, greater than or less than, but not equal to. We can imagine this set visually by drawing it out on a number line. When we draw out number lines, we're only going to concern ourselves with the boundaries, so I'm only going to plot 2 and 5. I don't need to plot the rest. The numbers that would fit in this set then, the smallest number would be 2. The biggest number would be 5, since I have to be greater than or equal to 2, less than or equal to 5. And any of the numbers that fall in between would fit in that set. So I'm going to shade the number line in between the upper bound and the lower bound. Notice that the circles are filled in. This shows that we have closed boundaries. Both 2 and 5 are included in our set. An open boundary would be an open circle, kind of with a hole in the middle. Interval notation is the third way that we're going to represent these sets. Interval notation puts the lowest number first and the highest number second with a comma in between. So 2, 5 would be our interval notation. And then outside of these numbers, we're going to put square brackets to show that we're including those two numbers, that we have a closed set. If we were not including those numbers, we would use parentheses to show an open boundary. Another way to visually represent sets is through something called a Venn diagram. Probably seen a Venn diagram before. It's circles that represent different collections of items, and we can compare 2 or more collections of items by having 2 or more circles overlapping. Each circle represents a collection or a set. In this case, we're going to be looking at people who have a dog and the people who have a sister. So the number of people who have a dog would fit into this circle that's been labeled dog. The people who have a sister would fit into the circle labeled sister. You can see that those two circles connect, they overlap. This overlap is called the intersection. This represents the and, people who have a dog and a sister. And again, this symbolic notation here is that upside down U. The other symbol, the U, this is called the union. This represents the or. We want to know the people who have a dog or a sister. So we don't care, they could have just a dog, they could have just a sister, they could have both. One of those two characteristics has to be true. So this would be represented by all of the items inside of these circles. Right? So this part here that I'm outlining in black, the circle in dog, but not in the intersection, this would be the number of people who only have a dog. This part in purple would be the people that only have a sister but not a dog. And then in green, again, the intersection, this would represent the people who have both. Inside of the Venn diagram, we can label or name the people themselves, or we can list the number of people. So let's say there are 30 people that we've surveyed, and there are 11 people in this intersection. 11 people have both a dog and a sister. Let's say there are 7 people who have a dog but not a sister, and there are 9 people who have a sister but not a dog. The one place that people often forget to look is the neither category. It's possible to have neither a dog nor a sister, and that number is going to go in the bottom corner on the outside of those two circles. So let's say there are 3 people that have neither a dog nor a sister. We can look at the number of items that belong in each collection. So let's say we're looking at the number of people who have a dog. This would be represented by all the people in the circle dog. So that's going to be both the 7 and the 11. So to find our total here, we're going to take 7 plus 11. There are 18 people in the circle dog that have a dog. If we want to know the number of people that have a sister and dog, we're looking at just the intersection. That would be 11 people. This N out in front represents number. We're looking for the number of people in each of those sets, in each of those parts of our Venn diagram. All right, here we go. The first thing that I looked for was whether this was open or closed. I see the parentheses around this interval notation, which means it's going to be open bounds. And I want all the numbers between 3 and 9. So on my number line, I have open circles on 3 and 9, and I've shaded everything in the middle. In the set notation, I've been sure to include both characteristics, that x is greater than 3 and x is less than 9. It is okay if you want to combine those into a double-sided inequality to show both of those characteristics, and then you wouldn't have to use the intersection. A couple other things to mention before you try some on your own. Again, remember to look for the closed boundaries, especially in interval notation. Those can be easy to miss. The square bracket means closed. We're including 3 and 9. Other thing that I want you to know about is called the complement. And that's this apostrophe here that you see on part B. This is again called the complement. And the complement means the opposite of. So if I have the complement of a set, I am talking about the opposite of that set. I want all the numbers not in that interval. So if I have the interval from 3 to 9, and I want the complement of that, I'm talking about all of the numbers not on that interval. So the interval from 3 to 9 would look like this on the number line. I'd have a closed boundary between 3 and 9, all the numbers in between. The complement of that would be all of the other numbers. So I'd have 3 and 9, but now I'd want anything not included that first set. So I don't want 3, and I want everything less than it. I don't want 9, I want everything greater than it. I don't want anything in between, since that was the original set. So in interval notation, we could also represent this complement as the numbers from -infinity to 3, open, non-inclusive, or the numbers from 9 to +infinity, non-inclusive. These two sets are equivalent, two different ways to write them. Here's one more opportunity to practice. You can go ahead and pause this video, try to fill in this table. On the far left, we have the number line. In the middle, we have set notation, and on the right, we have interval notation. See if you can fill in all the other ways to represent these three sets. Here are your answers. Double check the bounds, double check your symbols, union versus intersection, double check your shading on the number lines.